Hey, welcome back to edtech by Meera, and in today's tutorial we are going to talk about logical operators in Python. And what are the logical operators here? We are talking about or, and, not. So how do we use them? That is what we are going to talk about, how to apply them in Python. So let's see, without wasting much time, let's consider an example where you have a variable called num1, which is value with initialized with value of 10, and another variable num2, value as 7. So let's do magic with it to do our logical operators. Okay, so let's use the print function. Yeah, and give some conditions like, for example, consider a conditional statement like for printing, print num1 greater than 4 and so this is how you make the statement, the logical statement, num1 greater than 4 and with num2 something else. So num2 greater than or equal to 7. Now greater than equal to are all comparison operators. So we'll talk about them in a separate tutorial. Here we are just talking about the logical operators. So let's print that out and see. Usually in logical it will come true or false. So here it says true. Now why? Because obviously num1 is 10, so it's greater than 4. Num2 is obviously satisfying the condition that we have provided, equal to or greater than 7. It's not greater than 7, but at least it's equal to 7. Yeah, so it's coming out to true. Usually in a truly statement, if both the statements are true and you use the and logical operator, then the result will be true. Okay, then consider another scenario. So these are different ways you can write the and the or. Here we have written and, the and statement. So this means, and means in this case, the num1 variable is greater than 4 and the num2 variable is greater than equal to 7. So both. It means that way, like this much, so and the second one, so and so. Exactly means like that. Both, that means both. For both, it applies to both the numbers. Then the next one, let's consider another one where print num1, now print. So what you're considering the statement is num1, the expression rather, num1 is less than 4. Now num1 is 10. So obviously it satisfies the condition it's less than 4 and num2 less than equal to 7. Okay, equal to 7, so that should be cool. So it's true. Okay. Sorry, it's false because it's not less than 7. It's not less than 7, and number 1 is surely less than 4, but number 2 doesn't satisfy the condition. So that means when you write the and operator, if one of them is false, you will get a falsy result, output. And when you write the or condition, even if one of them is false but one of them is true, you will get the truly statement, output, sorry. So let's consider an or. So this is the rule. For and, either both true, then true, both false, then false. If one of them true, one of them false, then false. And for or, it doesn't apply that way. Even if one of them is true, it will be true. So let's consider this. Print. So this is the logical part of it. That's why we call it logical operator. We're using it for logical expression. So print. So now we want to know true or false. Num1 is greater than 1. Okay, 10 is greater than 1. And num2 is less than or equal to 7. Sorry. False. I wanted to write an or, so I wrote the. Okay. So num1 is, so one of them is false, so it works out to be false. Num1 is greater than 1, but num2 less than equal to 7. That's wrong, because it's supposed to be 7, either 7 equal to 7 or more, but it cannot be less than 7. Now if you use or, let's see what happens. That was for and. True. Why in the case of or it is true? Because one of them, the first one, num1 greater than 1 is true. So if in the case of or operator, even if one of them is true, the other one is not true, the output will still show you in the console true. So this is the rule, remember that. Because or stands for either and stands for both. So that's the reason. Now another logical expression, num1 equal means the value is 10, or num2, num2 whatever value is provided, we are using the same value, 7. So that is true because both are true. Num1 is already 10, num2 is already 7. So 10, 7 is, you are writing the or. So obviously the output will show you the truthy statement, true. The truthy statement, that is true. So the logical statement will give you in the console output as true. Consider another expression inside the print. Num1 greater than 1, obviously that's correct. Or num2, okay. Or now we use the not operator, not. So that is negating it. Not 2 greater than 1, not num2, greater than 7. That is actually the case. Num2 greater than equal to 7 is the case, but we are writing not outside it. Not means it's negating the provided value. So now in this case, why is it coming true? Because the second one is not true. The first num1 is greater than 1, it's true. So even if one of the number applies to the truthy value that is provided in the beginning, the initial value, and if the second one, which is not true, doesn't matter. When you use the or statement, if one of them is true, that is in this case num1 is greater than 1 is true because it's 10, right? So then your answer will be true. Let's consider another expression. Now here, the not operator you're using for the first variable, num1. So not num1 equals 10. That means it's actually negating the provided number. Initial number was num1 equal to 10, right? So here we are saying not num1 equals to 10. That means it's negating it and denying that it's 10. And then you use or num2. For num2 is equal to 7. So num2 in this case is correct, but the num1 was not correct. So it's showing true. Why? Because the second expression is true, but the first one is not true. But never mind, since you use the or condition, the or logical operator, it is giving you in the output truthy or true. So for or, that's the advantage. If one of the expression is correct, then it will give you a truthy. true. Let's use the AND operator with the same expression. It will give false, because I told you for AND, even if one of the value is not correct, it will give you false, because it applies to both. When you say Tom and Jerry sang, so that means both Tom has to sing, Jerry has to sing. I cannot say if Jerry is not singing, that means the statement will be not true, it will be false. When you say both, it should apply to both. In other words, in English, when you say, you remember like that, when you say and means applies to both. So both has to apply the condition. Correct. Truly. One cannot be truly, one cannot be false. But in or it doesn't mean, because it's either. Either Tom is fair or Tom is not fair. Either number one is positive or number two is negative. Something like that. Now another condition. Sorry. So let's consider a few more. Just one condition. One expression. Oh, by mistake I use the variable n1. It's supposed to be num1. The variable has to remain consistent, obviously. So let's make the changes accordingly. So num1 greater than equal to 1. It's the truth, but I added not, so it's not the truth. So it should show false. Obviously 10 cannot be, 10 is correct, greater than equal to 1, but cannot be not. Not means it is not greater than equal to 1, which is false. There you go, it should be shown as false. I hope you are understanding. So when you show not means not true. It is not correct. So I'm saying number 1 is not greater than 1, but 10 has to be greater than 1. So if you write not, it should produce a falsy. Means what you've written is false. It should give a false answer. If you had removed the not, print num1 greater than equal to 1, then it will be true, because obviously 10 is greater than 1. Sorry about the typo. Okay, we use the not operator with the second variable num2 less than equal to 7 or equal to 7. Either ways, you can try out different possibilities. Now num2 is actually 7, right? But if I say not means you are denying that it's 7. So obviously it will give a falsy reply. Falsy output, because it is num2 is 7, but we are giving an expression, logical operator, we are using not, which means it is not 7. So you are denying it. So obviously that statement will give in the output false, because the provided value is num2 is equal to 7. So I want you to try out with various numbers and examples, whatever that I'm giving with different numbers, so that you get it really correct. You have to try with different numbers. It's all about experimenting and practice a lot. Now, how do you use that in a function? You can use the logical operators in a function as well. So as usual, define a function called my function with parameter num. So let's use some conditional statements with num. Like num percent of 4. You know, we use the modulus operator for deciding whether it is multiple, divisible, and whether it's even, odd, right? So in this case, we want to know whether when divided by 4, the remainder should be 0. When divided by 2, remainder is 0. And then after that, after using the if condition, if num percent 4 or num percent 2 equals 0, print num is either a multiple of 4 or it's a multiple of 2. This we already know in mathematics. It doesn't need an explanation, right? Like for example, if you have a number like, for example, 8 divided by 2 will be 0. It won't, 8 divided by 2 is 4. What I mean is the remainder will be 0. It won't leave a remainder. So that's what we are saying when you use a modulus operator. So I'm not talking about modulus here. We are talking about logical operators or, okay, and then else print num is not a multiple of 4 or 2. That means if it gives a remainder, means obviously it's not a multiple of 4 and 2. If something is a multiple of 4 or something is a multiple of 2, the remainder should be 0. We all know that, right? Simple maths. But if anyone doesn't understand, I'm okay to explain separately to that person, or I can write it mention that in the comments. You can DM me as well. Okay, and then we call the function for different values. We've done this earlier, how to call a function. So my function for 25, 12, 8, blah, blah, blah. You can like call any set of numbers, any numbers rather, in order to run the program and test it out. Test the value. What result are you getting? Like for example, if you want to know 8, if 8 is a multiple of 4 or 2, you want to know, you call the function with 8 and then run the program, you'll get to know. But otherwise also we know, like if you divide 8 by 2 or if you divide 8 by 4, you won't get a remainder. So it's definitely a multiple. Obviously 7 is not a multiple of 2 and 4, but that is what you know in arithmetic. But here we want to show it and run it programmatically. Num is either a multiple of 4 and 2. Okay, there's a bug here because for 7 and 25 also it's showing it's a multiple of 4 and 2, which it shouldn't come. So there's some mistake in the code. So let's test it out, let's figure it out, let's debug. I think I know where it has gone wrong, so I'm gonna change. It was a typo mistake in the code. Okay, let's look at all the lines. Let's look at the first line where we've given the expression in the condition. Okay, I think I know why. Okay, if num percent 4 or, so before, remember when you write or and, you have to repeat the expression like this. Oh, wait. So first let me rule out all the unwanted statements and then just do for one value, run it for one number, and then let me go through the expressions like here. If num percent of 4 or, okay, I left out something. No, still wrong. There you go. If num percent of 4 equal to 0, or num percent of 2 equal to 0, it should be written like that. So it was missing, that's why the answer is coming wrong. So I'm going to fix that, and then it will be all right. Let's consider another example here of using the logical operator or an and in a function with if-else conditions. So as usual, we are defining a function using the if-else condition and then trying to decide whether it's a multiple of 4 and 2 or not, using the given provided conditions. And then we run the result, run the program, we return my function with whatever set of different numbers and test it out. Try with 8, 12, 7, 20, 25. Okay, so when you run it with OR condition, with some numbers it comes as it is a multiple, and with some numbers which are not multiples, it will mention that it is false, which is it is not a multiple of 2 and 4. Like for example, 8 is a multiple of 2 and 4 obviously. But is 25 a multiple of 2 and 4? We already know it is not, but we can test it out programmatically. Let's run it. No, it's showing a wrong. Yeah, now it says num is not a multiple of 4 and 2. Yeah. So earlier it was interfering with the previous answer, variable answer. That's why. So that's why I hid the previous result. So every time you do that, it's better to show the current result. So you can try it with different numbers for 12, 25, 28, 7, and then you try it out and let me know if it works for you. There you go. For 7, it's the same thing. It's not a multiple of 4 and 2, 4 or 2. So this way you can use the logical operator even in a if-else condition. In a function, particular given function. Just provide the conditions there. If, like for example, in this case, the modulus is 0, that means obviously when you divide 7 by 2, you will get a remainder. So in the previous example function, the reason there was a bug was because I should have written if num percent 4 or num percent 2, both the expressions should be complete. That is, if num percent of 4 equal to 0 or num percent of 2 equal to 0. Like that would have to write the if condition. So there was a mistake, but never mind, and now it's solved, so you can try it out. You can see it in the source code. I'll be including that in the tutorial. Okay. Next is we consider another example, which is a number which is initiated with a value of 70, and we want to use the NOT logical operator. Now, this is to show you that when you write NOT outside two expressions with an AND joiner, and you write or outside, it's the same. I'll show you how it is done. So let's get it done. Okay, now when I'm running the program, I'm getting the result of the previous one because we are using the same name for the variable. If you remember the previous, for my function, it was the variable was none. So here I need to change the name of the variable, otherwise it will interfere with the program result. So let's go to the main py. So you can, okay, I call it number instead of num. Yeah, so change it to number so that so that when you call num, it will show you the result of the previous function. Okay, so result is not, the not operator, and in the parenthesis you write number greater than equal to 1 and number number less than equal to 100. There you go. So not is outside, the not operator outside, and operator is inside the parenthesis, joining the two expressions, which is number greater than equal to 1 and number less than equal to 100. And the reason I'm showing this example is to show that this result is the same as another equivalent expression, which is not number greater than equal to 1 within the parenthesis or outside, not then again second parenthesis, not number less than equal to 100. So these two will be equivalent. So this is what I'm trying to show you. So let's write that out. But first and foremost, we didn't do the print function. That's why the result was not showing. Because here we are not calling the function. There's no function here. So, yeah, there you go. So you have to do the print. So it's showing a Boolean false. Now, why is it false? Because actually number 70 is greater than equal to 1 and less than equal to 100, right? But when you write the not operator, it means it is not. It's negating it, which is false because number 70 is obviously greater than 1 and less than 100. So, when you write a not, means it turns out to be a false output. So, it's a false statement if you write not. Ideally, it is true statement, truly. Okay, now trying with or operator inside instead of and let's run the program. It's showing you false because the same thing, it is not is outside. So if you write not outside, obviously even one of them is not false, both of them are true. Both of them are false if you write not outside. Not even one of them is correct, is true. Okay, go back to the previous one, not outside, and both the expression joined by and inside the parenthesis. Then we printed the result, which was giving a falsy or false Boolean. Then we write the next statement that I mentioned, equivalent expression, which we see here. Instead of joining both the expression with a not outside the parenthesis, we write not 2 times, repeat it for both the expressions. So not number greater than equal to 1, parenthesis closed for the first expression, joined by or outside the parenthesis. Next parenthesis inside is not, which is inside, not outside, mind you, not number less than equal to 100. Now both these expressions, the above one and the below one, are equivalent. This is what you have to remember. And the logic is correct because here you are saying the first number, the not number greater than equal to 1. Yeah, because that will be false, and not number less than equal to 100 also false. So both ways also you will get false. There you go. Because it's actually number is greater than 1 and less than 100. And when you say not, means you're negating it, which is a false statement. So you will get a result falsy or false Boolean. There you go. So this is what you have to remember. Let's consider some more examples. So for more, again, I want to thank all of those who are staying subscribed, and those who are not yet subscribed. The Python beginners are going to learn Python. You can refer to all my beginner lessons from day one. So I want you to click that subscribe button and the bell button so that you don't miss out on any of my Python beginner tutorials and projects, because I make them very easy to understand, both the projects and the explanation. So as you can see what I said, both the equivalent expressions are giving a false Boolean. And I hope you understood. If you do not understand, you can mention it below in the comments below. This is why it's called logical operators, because this is the logic behind the statement. You have to think very carefully. It's very tricky. Sometimes you might get it wrong because of the not, or, and add. So you have to consider it very carefully, the statement provided, and then answer. And then you can run the test to get your answer as well. So there you go. Consider one more example. Now here we are writing the result variable. We are storing the value of number greater than equal to 1 and number less than equal to 100, and there is no not over there, there is no or over there. Straight away, number is greater than equal to 1, and that means both. This means and means both. So both, it applies to both the expressions. Has to be that number is greater than equal to 1, and has to be that number is less than equal to 100. Now here it's coming true because both the expressions are true, right? 70 is obviously less than or equal to 100, less than or equal to, mind you, and greater than equal to 1. So it applies. So you have to look carefully at the statement, and you have to condition statement, and you have to look carefully at the operands. Operands means like whatever equal to sign, less than sign, greater than sign, because that will be the one deciding the that will be the one on which you will base the logic for your logical operator, and, or, and not. So you have to remember that carefully. Now we consider just one more example, last one. This is the logic behind this, that you want to check something. And what do you want to check? You want to check if a person is not old or foreigner. Not, that means is not old or not a foreigner. This is what you want to check. So this is the logic you want to check, and let's see how we make the expressions to equivalent expressions for this. Okay, let's say you have a variable called is old and is foreigner. So is foreigner for the nationality status, and we initialize is it with a Boolean false. So that means is foreigner. What does it mean logic wise? Is he a foreigner? Is she a foreigner? No. False means no, right? Not a foreigner. That means is not a foreigner. Is old? False. That means is the person old? No. The person, if I say the person is old means wrong. False. So that means the person is not a foreigner and the person is not old. That means young and not foreigner. I mean, this is how you have to understand. Just making you understand in the English way, the logic way. Yeah. And then you make two equivalent expressions to interpret this. So let's use, we can call it result 1, result 2, like the above example, or you can call it outcome 1, outcome 2. and then print out the two outputs, the equivalent expressions. So output 1, I'm going to store those values, those booleans, which is the expression which states, remember the one which the not outside. So not with the outside parenthesis is old or is foreigner. This is one expression for the first variable, output 1. That means is old, not, is foreigner, not, or. Now remember, not is old or is foreigner is equivalent to not is old and not is foreigner. You have to keep remembering this all the time. So the second expression we are writing, not is old, we branch it off separately, break it up. So the first one is equivalent to this one, not is old and not is foreigner. This is the same as above. It means the same as, that means the person is not old and the person is not a foreigner. This means straight away this. And the first one also means the same. This is why it's called equivalent expression. Now you want to print out the result from this expression, what value of the boolean it is giving. Is it giving a true value, a true boolean value of true or false? So print out the output 1 and print out the output 2 to see what result we are getting, whether it's the same or different. Obviously it has to be same because both means the same, they're equivalent expressions. This is quite interesting, right? Now, once we see the result, there you go. True, true. Now, why is it true? Simple logic. Is old is false, initial value, is foreigner is false, initial value. And both the expressions that you're giving means not old and not a foreigner. And the initial value that is giving also means is foreigner false means not a foreigner, is old false means not old. And the expression also means the same thing. But had you given the initial value, I want to try it out yourself at home. After doing this, you give the initial value of true to is foreigner, you give the initial value of true to is old, initialize. Instead of initializing with false, initialize both these above variables with true, and then you run the same expressions for output 1 and output 2. Then you will find when you're writing not is old or is foreigner and not is old and not foreigner, you are negating the truthy that was given to you, right? Then it is opposing the initial value. In that case, both output 1 and output 2 should give you a boolean value of false. I hope you understood, and I really want you guys, all of you watching this tutorial, to try that out with the true values for is old and is foreigner. Run the test, the same expression, and let me know what happens in the comments below. I want all your replies. Yeah? So I hope it is clear, and I'll be coming up with more interesting ones. But remember to comment below the last exercise so that I know that you are keeping engaged. Let me know. See you in the next.